All right, so I believe we're live. Let me just take a moment. So, welcome. Revisiting revisiting a problem that we looked at yesterday. I took quite a lot of time looking at it the other day, learning about it, and I wanted to take a look at it again today because I thought about it some more and I realized I took kind of a foolish approach, we'll say. Not that it was that foolish, but let's just say that the approach that I took wasn't quite the best, and I realized there was a much better way to do this. And so we're going to give that a shot. Basically, I'll read the problem again, just to give you an idea, and then I'll explain the actual solution that I'm going to go and ultimately go with, and then we'll try to code that up. And that shouldn't take too much time. It really shouldn't be too bad. We'll see how it goes. You're given an m by n integer matrix, heights representing the height of each unit's cell on a continent. The Pacific Ocean touches the continent's left and top edges, these ones, and the Atlantic Ocean touches the continent's right and bottom edges. So these ones are the Atlantic, these ones are the Pacific. Water can only flow in 4 directions, up, down, left, and right. Water flows from a cell to an adjacent one with an equal or lower height. So from 5 you can go down to 3, 4, 2, and to the Atlantic Ocean, or you can go up 3, 2 to the Pacific Ocean, right? Because each of these are lower, subsequently lower. Return a list of grid coordinates where water can flow to both the Pacific and Atlantic Oceans. So I was really confused by this initially, but they're saying water can flow to both means that if you put water there, it could flow to the Pacific and to the Atlantic. And so you see these have like a slightly different shade of white. It looks like slightly gray. These values. These are values that could flow to both. Water in that spot could flow to both Pacific and Atlantic. And so what I'm going to look to do is give an algorithm that will find these cells. So what I realized is that this could be achieved relatively easily using like a flood fill algorithm. And I'll explain how that works in a moment. And basically a flood fill, so actually I'll explain right now. So what I would do is I would say, okay, I want to know all the cells that can flow to the Pacific Ocean. So I'm actually going to start from the Pacific Ocean positions, and we're going to iterate on each one. We're going to try each one. Excuse me, we're going to look at all 4 directions. And if we're in bounds, then we're going to say, okay, if that height is greater or equal to the height that we're iterating from, then that means that we could get to the Pacific Ocean from that position. So like from 2, this 2, all of these obviously are sort of true to begin with, but this 2, because it's the same height, it's greater than or equal, this 2 to this 2 would means that this 2 can reach the Pacific Ocean. So basically, any position that you can reach, therefore, any position that's greater than or equal to the point that you're looking at is also going to be given that the point you're looking at can reach the Pacific Ocean, any of the positions near it in the up, down, left, right position are also positions that can reach the Pacific Ocean. And so you can do what's called basically a flood fill algorithm where you just kind of keep iterating on all of those, and you don't revisit any ones you've already visited. And yeah, and that's pretty efficient. That's O of m times n. And in the worst case, it touches every value in the grid. You do the same thing from the other side for the Atlantic Ocean, and you're not going to, even though you're going to iterate on you're going to begin from each of these positions. Due to how the flood fill works, more likely than not, you'll have covered most of these anyway each time. And so you don't do very much extra computation. So you do, at most, a linear amount, O of n plus O of m extra time operating on all of these elements, which is is computationally dominated by O of m times n. So that's it. That's super straightforward. I'm going to write a lambda. I'm going to write a subroutine to do this, and then at the end you can take your you could just combine the arrays that you have of the ones that were reachable by the ones that could reach the Pacific, and then combine that with the ones that can reach the Atlantic. Take that intersection of those values of those pieces, and or of those grid coordinates. Take the intersection of those grid coordinates that have those two properties, and then return those. That's it. Super simple. Should be super straightforward. So I kind of have the beginnings. I spent like quite a bit of time, but I have the beginnings of a flood fill algorithm. So we're going to try again, and I'll show you what this is going to look like now. Okay. Well, yeah, we'll modify this. So number of rows, number of columns, and we have visited Pacific, Atlantic. That's fine. We are going to have an inbounds check. That's fine. So we'll have a flood fill, RC. We don't need a phase anymore. We do want to give F so we can call our recursive function from itself. And then we also want two things. We're going to go ahead and do this. Actually, we want a grid bool reference, and this is going to be the visited set, and this is also going to be the result set, and I'll explain what the purpose of that is shortly. So we process, we say if we're not in bounds, we're going to, we don't actually need to return anything either, by the way. The way we're going to do this, it's every element that we touch automatically gets a value, so it doesn't matter. And we actually don't even need a visited set either. We can just do result set, and in which case we don't need a visited set anymore either. So yeah, that should be fine. So we have a result set, and we say if not in bounds, return. Forget the phase portion, and if this part is already true, also return. It's not in bounds, or if it is in bounds and we have result of RC, then we return. We're not going to process things we already visited. And then result, set it to true, where we visited this spot. And then recurse on neighbors with a greater or equal height. And we don't need to have a check. Have our 4 different directions. We loop through those. We say if we're inbounds, and we technically don't need to check the inbounds check here because we put the inbounds check over here before. We could we could put it in both places. I guess it doesn't matter. In that case, we don't necessarily need this. This actually is part of the processing. Process RC. Well, position, yeah. Okay. Right now we want greater than or equal to, and then we'll iterate on that. And there's no phase anymore; it's just the result. 1, 2, 3, 4, right? Yeah. So that's it. Super simple. Really simple. I mean, you see that? Super simple. And now we would say process that can reach the Pacific. Yeah, right. So it's going to be rows. This is going to iterate over all the rows, which means it's going to be the first column. And we're going to take these. Here. We don't need this anymore. So we're going to populate the Pacific and the Atlantic using the same routine. So we flood fill over the rows, where the column is the first column, and we say Pacific is the result vector, or result vectors we want to modify. This is the same kind of a deal on the other side, where the first row, row we're going to process. So this the row doesn't change, but the column is going to change. Again, Pacific, and yeah. If we've already visited that spot, we just return. So then that's it for the Pacific. Same thing we want to do for the Atlantic. How are we doing on time? 11 minutes? Okay. Atlantic, we're going to use the Atlantic. All right, code reusability here. And we're actually going to go the other way. We're going to say the row is, it's going to be a similar thing. The row, it's going to be the last column, so number of columns minus 1, and this is the last row, which is number of rows minus 1. Right, the indices for those rows and columns. So right, this column will progress across here, and this row. So this is going to be the iterating over the last row, and this is iterating over the last column for the Atlantic. And then we say we don't need any of these things anymore. Positions that can reach both Pacific and Atlantic will be pushed into the return vector. Yeah, that should be it. I think that's all you need. Unknown type name grid bool. Oh. Oh, there we go. And let's just go for it, see how we do. Well, at least try another test case. We could just throw in some random test cases. Let's do that. Oh, it couldn't hurt. I just want to go for it though. Have a degree of confidence in this one. Let's go for it. All right, got him. Pretty straightforward. Now, are there ways to optimize this? Probably. Do I have a really good idea of how? Not really. You could probably do this using a different kind of traversal. You could do like a breadth first search traversal also. Yeah, I mean, this is super simple. Just wondering if there's a more efficient way to do this. Oh, okay. No, that's about it. That's interesting. Okay, 93%. Yeah, that's about as efficient as it gets. Nice. All right, done. Moving on. I think I explained it. I think hopefully that makes some sense. There are a lot of pieces in here that are kind of relatively straightforward to code up, I guess. Kind of a standard approach to this flood fill kind of a thing. Yeah, it should be not too bad. A little bit embarrassed it took me so long the other day to figure this out. Not too embarrassed. I mean, it's not that easy, you know. It's not that simple. Also, suddenly feels like my volume is a lot higher. I don't know what's going on. I guess I think it's because I'm feeling a little more confident speaking. And once I get going, I speak a little bit louder. Yeah. So that's. I think that's it. I think that's it. I don't really want to. Yeah. Okay. Okay. So thanks for watching. Thanks for watching. Talk to you soon. And yeah, I think I'll take a small break and probably get into another problem. So yeah, take care.